So today we will just discuss about a very important term in the chapter of electricity called resistivity. Before discussing on resistivity, let us recall the important concepts which we have learned in this chapter. So chapter number 12, electricity. Okay, so let's quickly recap what we have learned in previous sessions. So the first important term for us definitely is the electric current. So you can just give a thought and try to recall what I mean by this word electric current. So electric current is simply the flow of charge, or you can say whenever electron moves from one place to another, we say the current is flowing. Okay, so as mathematically we can say कि if q coulomb of charge flows through a cross section in unit time, then it is defined as the current flowing through the conductor. As you can see on the screen, if a net electric charge q flows through a cross section of a conductor in time t, we say current is flowing through the conductor. And mathematically we have seen that current is defined as a ratio of the charge upon time, and the unit for measuring this current is amperes, and the unit to measure charge is coulomb, and as we all know the SI unit for measuring time is in seconds. So this is the first formula which we have learned in this chapter. It is used to calculate the current flowing through any device or any conductor, and current flowing is nothing but the flow of charge. So how much charge flows in unit time gives us the magnitude of the current through the conductor. And then second important term which we have studied is obviously the potential difference, also called as a voltage. Okay, so potential difference or voltage, as you can see here. So voltage is another term which you can use in place of potential difference. Also you can use the term called EMF, the electromotive force. And as you can see now on the screen, electric potential difference, also known as the voltage, is equal to the amount of work done to move a unit charge between 2 points against the electric field. Now from where this electric field comes, if you recall, this electric field is provided by the cell or the battery or any source of electricity. And since electrons are moving, and as we know in physics, whenever we say work done, so whenever you are applying force on any object, if object moves, we say that we have done work. So since electrons are moving from one point to another point, then naturally they are moving under the influence of the potential difference. Or in other words, you can just give a recall. We have seen that the electrons being negatively charged are repelled by the negative terminal of the battery and they are attracted towards the positive terminal of the battery. So definitely the work done in moving these charges from negative to positive terminal is actually defined as the potential difference or the voltage. And mathematically we can write this as voltage is equal to work done upon charge moved. Okay, definitely when current flows, not a single electron flows, multiple electron flows at the same time. So how much charge is flowing and how much work is done to move that charge gives us the measurement of the term voltage. And simply in mathematical terms we can write as V is equal to W upon Q, where V is nothing but the potential difference or the voltage. W is the work done in joule and Q is the amount of charge that has been moved from one point to another point. And if you recall, the unit for measuring the potential difference or voltage is actually volt and it is denoted by the letter V. And this volt name comes in the honor of the Italian physicist Alessandro Volta. This already we have seen. So till now we have recalled two terms, the electric current and the potential difference, and recall that our today's topic is to understand resistivity. But before starting and trying to understand resistivity, we are recalling what we have learned previously in this chapter. And next very important, Ohm's law. Okay, so now there may be definitely many questions like how much current will flow for how much voltage. Yeah, to make this much current, how much voltage is required to be applied. So the answer comes from the Ohm's law of such questions. So if you recall Ohm's law given by Simon Ohm, so it simply states that the potential difference applied across any 2 points will make a current to flow through the conductor and this current will be directly proportional to the electric voltage or the potential difference applied. So as you can see, the complete statement for the Ohm's law goes like this. Ohm's law states that the potential difference between 2 points is directly proportional to the electric current and of course at a constant temperature. This condition is very important because if temperature is not held constant, definitely this law will not be followed. So mathematically I can write this as V proportional to I. And as we all know, whenever we remove this proportionality constant, we introduce a constant and this constant is actually called as R, which is called as the resistance of the conductor or the device. So as we can see from Ohm's law we have got this relationship which we called as V is equal to IR and R is a constant for a given conductor at a given temperature, because if the temperature is not maintained, naturally the resistance will vary with respect to temperature. So this is a very important condition for the Ohm's law to hold true, that the temperature must be held constant. Okay, so now with these three things, the electric current, the potential difference and Ohm's law, we get the basis to understand the term resistivity. Now the obvious questions are what is this resistivity? How it differs from that of the word resistance? On what factors the resistance of a conductor depends? So let's go and quickly find out what I mean by this word resistivity. And naturally resistivity relates to resistance. So just now we have seen that resistance basically is a constant in Ohm's law, and the unit for measuring this resistance is ohms. So now this resistance of the conductor, basically of any metallic conductor, as you can see, is directly proportional to the length of the conductor, and it is inversely proportional to the area of cross section. So mathematically I can write it like this: R proportional to L, है ना? The resistance will be more if the length of the conductor will be more. Resistance will be less if the length of the conductor is less. And it is inversely proportional to the area of cross section. So mathematically I can write it like this: R proportional to 1 upon A. That means they are inversely proportional. And now I can just combine these two equations. And if I want to remove this proportionality symbol, naturally I have to introduce a constant. So this constant is actually called as rho. And this constant rho is actually termed as resistivity. Okay, so let's quickly recap. As we have seen, the resistivity of uniform metallic conductor is proportional to the length of the conductor. It is inversely proportional to the area of cross section. So mathematically we got a relation called R equals rho L upon A, where rho is actually termed as the resistivity of the conductor. And of course that resistivity depends upon the material. Let's find out more on this word and this term resistivity. So resistivity is a constant of proportionality. Okay, and this, it is denoted by the letter called rho, RHO we write. So it is the electrical resistivity of the material of the conductor, as you can see here, and the SI unit for measuring rho is ohm meter. Okay, now how this unit comes ohm meter we can easily determine. So we can just have a pen. Just for example, we know V R is equal to L into rho upon A. So this can be written as rho R into A upon L. And now we know the unit for R is ohm. For A, the SI unit for length is meter. So definitely area is multiplication of 2 length. So meter square upon meter. And this meter will cancel this square, and the unit for resistivity comes to be ohm meter. Okay, so remember there is a very important thing: the unit for resistivity is ohm meter, as you can see here also. Now, as you can see here, the resistivity of conductor is very low, whereas the resistivity of insulators is very high. Okay? Of course, no, because conductors should allow the current to flow through them. So their resistivity is very low. And the job of the insulator is not to allow the current to flow from it. Therefore, their resistivity should be very, very high. And a very important thing to be understood is that resistivity varies with temperature. And we all know the heating effect of electricity, due to which any device or conductor becomes hot when current flows through it. So when conductor is used for a long time, definitely it will become very hot and its temperature is going to increase. And this increase of temperature will increase the resistivity of the conducting material. And if definitely the resistivity increases, the resistance will increase. And if resistance increase, the current is going to decrease. And we all know all devices are actually developed to work for a particular value of current and voltage. So if current is changed, the device naturally will malfunction. That's why computer labs have AC, ATM room have AC, so that they can maintain the normal temperature just to keep this resistivity under limits. Okay, so remember, resistivity of conductors is very low and insulators have a very high resistivity. So what can I do? I can have this picture now in front of me. Sometimes we are not using pure metallic conductors. Instead, we are using alloys also, which is actually a mixture of some metals. So as you can see here, alloys having a high resistivity than metals. So now the question is why we require high resistivity materials. Now just imagine electric bulb, electric heater, electric toaster. They all work on the principle of heating effect of electricity. So naturally their resistance should be very high, no? Then only that heat will be produced by those devices. So their coil is made up of actually alloys. For example, in electric iron, or we are using tungsten for creating the filament of the electric bulbs. And copper and aluminium, as we see, they are used for the electrical transmission. Okay, so just continuing with the resistivity, we have seen now there are three things: metals, alloys, and insulators. As you can see, the resistivity of conductor, resistivity of alloys, and resistivity of insulators. So resistivity of alloys is more than that of the resistivity of conductors. However, the resistivity of alloys is less than the resistivity of insulators. As you can see, this table will also indicate very easily, for example, silver as the conductor is having the resistivity 1.6 into 10 raised to minus 8 ohm meters, whereas alloys have, for example, this anyone you can take nichrome 100.0 into 10 raised to minus 6. And if you just check the resistivity for the insulators, so they are of the order 10 raised to 10 to 10 raised to 16, 15. See the order here, the power of 10 is positive in case of insulators, and the power of for conductors and alloys is negative. So naturally insulators have the highest resistivity. Now, after understanding the theoretical part and the term resistivity, we are often found numericals on this topic. For example, one question is in front of you. Just go through it first of all, then we will discuss how to solve it. Okay, so if you just read the question, it says that a wire of length 3 meter and area of cross section 1.7 into 10 raised to minus 6 meter square has a resistance of 3 into 10 raised to minus 2 ohms. So there are two parts for this question. The first one is very simple because just now we have seen the formula for calculating the resistivity. So the first part says what is the formula for resistivity of the wire and what is the unit of it. Just now we have seen the relation R, that is capital R, is equal to rho L upon A. This relates length, area of cross section, resistance of wire to the resistivity. And unit, of course, we know it's the ohm meter. Calculate the resistivity of the wire. Let's see how we can solve this problem. The first part is definitely very simple. So here is the formula that we have already learned just now. R equals rho L upon A. And now to get the resistivity, we can just do some transformations. And rho becomes R into A upon L. And of course, the unit for measuring resistivity is ohm meter. Already I have shown you also how this unit is derived. Okay. Now let's move on to the second part. And as usual, for all numericals, first of all, we have to write the given things. So length of wire is given to be 3 meter. Then the area of cross section of the wire is given to be 1.7 into 10 raised to minus 6 ohm meter. And then also we are given the resistance of the wire, which is given to be as 3 into 10 raised to minus 2 ohms. And now we are required to determine the resistivity. So we just substitute for you to recall. Rho क्या था formula? What was the formula? Rho R into A upon L. So we just substitute the value for R, for area of cross section, and the length, as you can see here. So R is 3 into 10 raised to minus 2 ohms. A is given to be 1.7 into 10 raised to minus 6 meter square. And the length of the wire is 3 meter. So thus substituting the value, we will have 3 into 10 raised to 3 into 10 raised to minus 2 into 1.7 into 10 raised to minus 6 divided by the length, that is 3. And if we just simplify it, we will get this value as the answer for the resistivity of the conductor for the given problem. So this simple problem shows us how resistivity can be calculated for a given value of the resistance of the conductor, the length and the area of the cross section